Hello everyone, I am Ganesh Mirajkar. I am a lecturer in Civil Engineering Department at BMP Solapur, and today we will discuss about the framed structure, its components and their functions. This presentation will help the students to understand the functions of building components. So in the picture, typical RC frame building is shown. This horizontal plate-like structure is known as slab, which is resting on a horizontal member which is known as a beam. So beam is connected with the column, a vertical member, and this column is supported by this element which is known as foundation, and the foundation is supported by the hard soil. So basically, dead load, live load, wind load acts on the structure. So dead load is the load which is stationary and not changing its magnitude with time, for example self weight of members. Live load is a moving load which is not stationary, for example vehicle load or student sitting in a classroom. Wind load acts uh, due to the wind pressure. So in frame structure, load transfer is from slab to beam, beam to column, and column to foundation, and the total load is transferred to the hard soil strata. During this load transfer, some actions are applied on the members. If member gets pushed, that action is known as compression. If member gets pulled, that action is known as tension. If member gets bent, then that action is known as bending or flexure. If member ends are twisted, that action is torsion. If some part of the member is moving in one direction and another part is moving in opposite direction, that action is known as shear. So generally the material used for the construction of a framed structure is reinforced cement concrete. So concrete is a mixture of cement, fine aggregate and coarse aggregate. So cement is used as a binding material. So it consists of lime as a major component, that is 60 to 65%, then silica, then alumina, then magnesia, sulfur trioxide, alkaline iron oxide, calcium sulfate, etc. Okay. Then coarse aggregate is the aggregate which is having size greater than 4.75 mm up to 35 mm to 40 mm likewise. And fine aggregate is the aggregate which is having size less than 4.75 mm. So depending upon the compressive strength requirement of the concrete, the grades of concrete are based. For example, M5 indicates M5 grade corresponds to the proportion 1 is to 5 is to 10. So one part of cement, 5 parts of fine aggregate and 10 parts of coarse aggregate. So torch steel have higher yield strength. This is the picture of torch steel than mild steel. So it is a less ductile as it consists of less larger component content of carbon, means as carbon content increases ductility decreases, and mild steel is having a plain surface round bars, round bars, but they are more ductile than that of the torch steel, but torch steel having larger yield strength than that of the mild steel. So this is the graph which shows that as the carbon content increases ductility decreases, so dependent on that we can classify the steel as high carbon, that is strongest, toughest and most ductile. If the beam is just kept on the supports at its ends, that beam is known as simply supported beam. Okay, so due to external load, the tension is occurred at the bottom fiber and the top fiber carries a compression. Okay, in the second part we can see that if one of its end is fixed, then the tension occurs at upper fiber and compression occur at bottom fiber due to the external loading. So this is the effect of flexure. The bottom face stretches in tension and vertical cracks will develop, and the shear cracks are developed due to shear effect at angle 45 degree. So avoid the flexural failure, we require steel reinforcement at bottom, and to avoid shear failure or to balance shear stresses, stirrups are used. So these component or these members are known as stirrups. This reinforcement is known as stirrups, which is a loop of less diameter bars. To avoid failure or to balance shear stresses, these stirrups are used, and stirrups holds the main reinforcement in position. Also, it prevents the diagonal tension cracks. So, when we consider a beam column joint, certain amount of extra length is required to be embedded, that is known as development length. It is required to establish bond between steel and concrete. It also transfers the load from beam to column. It prevents the bar from pulling out under tension. Okay, and the splicing is known as joining of two bars by overlapping. That overlap is nothing but the lap length. So this is a typical beam column joint. Any L-shaped extra length of reinforcement for the anchoring purpose or bond purpose is known as bond length, which may be in the beam column and column foundation. Okay, it is for just for a as a grip to have a proper bond between concrete and steel. Now, one-way slab and two-way slab. So in one-way slab, loads are carried along one direction. In two-way slabs, loads are carried along both direction. So in one-way slab, bending is in one direction only. Slab is supported on two opposite edges. In two-way slab, bending occurs in both the direction, and the slab is supported at all four sides. Okay, this is the picture of one-way slab and this is two-way slab. If Lx upon Ly, that is the ratio of two adjacent sides, is greater than 2, then that slab is known as one-way slab. If Lx upon Ly ratio is less than 2, that slab is known as two-way slab. So load transfer in one-way slab is this. If we assume this center line, then half of the portion will be transferred to this beam and half portion will be transferred to this beam. And for two-way slab, this beam will be carrying a triangular load and this will carry a trapezoidal load. Okay, so as far as reinforcement is concerned, in one-way slab, so main bars are along the shorter span, that is parallel to the shorter span, and distribution bars are parallel to the longer side. So function of or reason why we provide main bars is to balance the deflection in that direction, and distribution bars are to just balance the stresses developed by temperature variation and stresses due to shrinkage. For two-way slabs, main bars are provided parallel to the shorter span and longer span. So this is the failure of column. Column is a, we know that column is a compression member, that is the force is acting along the axis, so it can be eccentric, that is it can provide a certain moment action in the column, and the failure will be due to the buckling. Buckling means this type of variation, this type of displacement. Okay, so there are two types of reinforcements in the column. Main steel can take mainly compression and tension as per the requirement, and lateral ties are provided to resist the buckling and to hold the main reinforcement main bars in the position, that is to increase the ductility. Now these columns are resting on the foundation. There are some types of foundation. If depth is less than the breadth, then we can call it as a shallow foundation. Strip or wall footing, in the picture strip or wall footing, simple and stepped footing are given. This is constructed for load bearing wall, means the, the wall is carrying the load. If the wall is carrying the load, this kind of footing can be provided. For single column load or single column, we can provide the isolated footing. Okay, these are some types of footings: simple footing, slope footing, and stepped footing. Combined footing: if two or more column in straight line are to be supported by a single footing, then we go for combined footing. Okay, and if the loads on the column of combined footing are same, then these columns are same, then we go for rectangular footing. And if the loads on these columns are differ, means one column is having heavy load than that of the second, then we go for trapezoidal footing. Mat footing, uh, we can say it as a raft footing. For the it is suitable for the soil of low bearing capacity for heavy loading. And we can see that there is a slab which supports 3 or 4 or 5 number of columns. So strap footing is nothing but a footing in which two or more footings are connected by a beam. It connects eccentrically loaded column close to the property line. Pile footing is one of the deep footing in which the load is transferred to the hard strata which is available at greater depth. Now, pile footings are classified as end bearing pile, friction pile. So end bearing pile means the load is transferred by the pile end which is resting on hard strata, means this load is transferred at the soil strata by this pile end. So reaction is developed over here. In friction pile, the load is transferred by this pile by means of the skin friction which is developed along the periphery of the column and due to the interaction of soil and this pile surface. And it can be a combination of these two. And underrimmed pile is used when uplift action of the forces can occur, means if structure gets lifted up due to certain actions of air or water table, anchoring is required. For anchoring purpose, this kind of footing is required. Thank you very much.